Hey there, what's up? This is Tasin Khan, and I'm a third year medical student at the Bangabandhu Sheikh Mujib Medical College, Faridpur. And today I'm going to talk about a very important topic, that is the thyroid hormone synthesis. And it is very important for the MBBS journey. And so let's begin. Mainly in the thyroid hormone synthesis, there are mainly 8 steps. We can see that there is the flow chart here. The 8 steps are really important, as because if we think about the other hormone synthesis system or other hormone synthesis, the synthesis of other hormones are really in a different way. They synthesize in a different way that is similar, but the thyroid hormone synthesis is really different from them. It's a peculiar one. So for that reason, it is divided into 8 steps, as because why we are calling it peculiar, because it requires iodine. The main the active hormone here is the T3, but it is not synthesized in a proper way, or it is not synthesized in adequate amount in the body. The T4, which is not active in thyroid hormones, it is synthesized in more, synthesized in very adequate or more in the body. So if we just talk about the first step, that is the thyroglobulin. Though what is the first step is the synthesis of thyroglobulin. The synthesis of thyroglobulin, we can know that the thyroglobulin is a glycoprotein which consists of the tyrosine. Tyrosine, we know that tyrosine is an amino acid. After that, where the tyrosine is synthesized? The tyrosine is synthesized in the endoplasmic reticulum and Golgi body. Okay. In the Golgi body and the endoplasmic reticulum, then the thyroglobulin is transported from the follicular epithelial cell. So first of all, we have to say, I say that in the thyroid hormone synthesis, we have to consider 3 things. First one is the blood or systemic circulation. The second one is the follicular epithelial cell, and third one is the follicular lumen. So in the follicular epithelial cell, thyroglobulin consists or exists. Then thyroglobulin is transported from the follicular epithelial cells into the follicular lumen. Okay, this is the first step. In the second step, we can say that is the sodium iodine co-transport, or the iodine trap. In the sodium iodine co-transport, we can say that the iodine is transported from the systemic circulation or the blood into the follicular epithelial cell. How it is transported? It is transported with sodium. We can say the co-transport is because it is transported from the blood with sodium against the electrical or chemical gradient. Okay. So when there will be a dietary deficiency, when there is deficiency of iodine in the blood, at that moment that the sodium iodine co-transporter will be stimulated. This is the second step. So in the second step, we have learned that the iodine is transported in the follicular epithelial cell, and after that, in the third step, we can see the iodine ion is transported into the follicular lumen, where it is converted into iodine by the enzyme thyroid peroxidase. Then in the fourth step, the thyroglobulin and the iodine is attached together, and it forms the MIT and DIT, monoiodotyrosine and diiodotyrosine, by the help of the enzyme thyroid peroxidase. Okay, these MIT and DIT are attached with the thyroglobulin. They remain attached with the thyroglobulin. Okay. After that, in the fifth step, so I have missed something, that the fourth step, the third step was named as oxidation of the iodine to iodine. Then the fourth step means the organification. Then comes in the fifth step, that is coupling reaction. In the coupling reaction, what does it happen? That these MIT and DIT, while they are connected to the thyroglobulin, these MIT and DIT are connected to each other, or they get coupled. So when they get coupled, one MIT and one DIT makes the T3, and one DIT and one DIT. So 2 DITs make the T4. They are our main hormones. So these 4 things, T3, T4, MIT and DIT, these 4 things are connected or attached with the thyroglobulin. Okay, and this thing happens by the enzyme thyroid peroxidase. So we can say that the thyroid peroxidase enzyme is very, very, very important. After that, these thyroglobulin is endosized. Endosized means it goes back from the follicular lumen to the follicular epithelial cell. So the thyroglobulin in which the T3, T4, MIT and DIT are attached, they goes into the follicular epithelial cell. Okay. After that, there will be hydrolysis. What is the hydrolysis of which thing? The T3 and T4. The hydrolysis of the T3 and T4 by the lysosomal enzyme. So what does happen? These T3 and T4 are hydrolyzed by the lysosomal enzymes and they got free. And they are moved from the follicular epithelial cell into the blood or in the systemic circulation. So what really remains in the follicular epithelial cell is the thyroglobulin attached by the MIT and DIT. And the last step is that which is called the deiodination of MIT and DIT. In the deiodination of MIT and DIT, these MIT and DIT are being excluded from the thyroglobulin. So when the MIT and DIT are excluded from the thyroglobulin, after that the MIT and DIT are also being excluded, so they are being separated. As we know that the MIT and DITs are mainly made up of the iodine and the thyroglobulin. So the iodine and the thyroglobulin are separated, so the remaining iodine that goes into the intercellular pool, and sometimes it goes to the sodium iodine cotransporter. So it helps in the sodium iodine cotransporter when there will be iodine deficiency in the circulation. At that moment we know that there will be a stimulation. So this is all about the thyroid hormone synthesis.